Hello and welcome to the first unit for Physics 221. In this unit, first part, we are going to be covering units and conversions that we will be using in this class. This is a science class, so as such, we will be using the base units for the SI system, kilogram for mass, meter for length, and second for time. Because we are going to be working in the SI system, sometimes known as the metric system, you will also need to know and be familiar with the metric prefixes. So for example, 1 kilogram tells me, I look at kilo, that tells me that there are 1,000 grams in 1 kilogram. On the other hand, I could have a milligram, down here milli, and that tells me that 1 milligram is 1,000th of a gram, or in other words, there are 1,000 milligrams in 1 gram. I don't expect you to memorize all of this, though it's not a bad idea. Most likely the ones you will need in my class are kilo, centa, and milli, and so it'd be really good if you are familiar with those. There are many ways of converting units. I teach one. I know 3 or 4 different methods that people like to use. If you have a method for unit conversions that you know, you love, is different than mine, but is done in an understandable way, you are more than welcome to use it. It's not a problem. I can read anything. So when I do it, I think about converting units as multiplying by fancy factors of 1. These fancy factors of 1 are things that are equivalent but look different. Okay, a lot of people call these conversion factors. But if you think about multiplying by 1, it doesn't make any difference to the number you're multiplying by. Anything times 1 is itself. So what's a common fancy factor of 1 for me? Well, I've already listed 2 of them. But for example, I could have 1 kilogram on the bottom and 1,000 grams on the top. Top and bottom look different, but are equivalent measurements, just in different units. Let's do an example. Okay. A cheetah can run at speeds of up to 120.7 kph. That stands for kilometers per hour. For short bursts, he can do this. We want to convert that to the rather esoteric unit set of furlongs per fortnight. And I give you a little bit of help here, that 1 furlong is 660 feet and 1 fortnight is 2 weeks. So the way I do my unit conversions is I take my initial factor and set it equal to itself. I know that this has to be a true statement. And now here's where those conversion factors come in, the fancy factors of 1. So I'm going to start by converting the numerator. I need to get from kilometers to feet, and then I can get easily from feet to furlong, which means the first thing I need to do is get from kilometers to something that is an English unit system. There are a couple of unit conversions you might know to do this. You might remember that there are 2.54 centimeters in 1 inch. You might also remember from maybe running the mile in your PE class in high school, that 1 mile was 4 laps around a track and each lap was 400 meters. So that gets you to the fact that 1 mile is 1,600 meters, or you might think about that as 1.6 kilometers. Yes, this is good enough for me. In actuality, this conversion factor is 1,609 meters. But if you just want to call it 1.6 kilometers, that will be sufficient for me for this class. Okay, so let's use this one because it doesn't require me to go all the way down to centimeters and inches in order to come back up. Might be better, might not, because now we've got to be able to get from miles to feet, but I happen to know that unit conversion too. Okay, so I know that there are 1.6 kilometers in 1 mile. And I've set up my conversion factor so that the denominator of my conversion factor cancels the unit I am trying to change. Okay, and now I need to get from miles to feet. I know that 1 mile is 5,280 feet. So I'm going to put that in. Again, miles cancels. And now I can use that 660 feet is 1 furlong. And if you look, my units are now furlongs per hour. So now I need to get from hours to weeks. I can either do a multiplication here and go on, or I can just keep multiplying. I'm going to choose that latter option. So let's see, I'm in hours. I know that there are 24 hours in 1 day. And notice, since hours was in my original denominator, I put hours in the numerator of my conversion factor. I know that there are 7 days in 1 week. And now I can use the fact that there are 2 weeks in 1 fortnight. And you can see my units now that remain is fortnight in the denominator and furlongs in the numerator. Okay, so now we grab our favorite calculator, 120.7 divided by 1.6 times 5,280 divided by 660 times 24 times 7 times 2. And that works out to be 2. I'm just going to write this down and we'll figure out the decimal place here in a minute. My calculator is in scientific notation, so I got to count decimal places. So 1, 2, 3, 4, 5. Okay, so it's 202,776 furlongs per fortnight. It's not a big surprise that this is a huge number, considering that 1 furlong is a fair few number of feet, but 1 fortnight is 2 weeks, right? Okay, moving onward. In this class, you may also be asked to convert areas or volumes. It is not difficult to do if you know the trick. So here we want to convert 10 meters cubed into kilometers cubed. I'm going to begin by the exact same method I had before. I set my initial piece in equal to itself. And now I am going to do my conversion. I know that 1,000 meters is 1 kilometer. Okay. And I see my units here are cubed. So I need to do this conversion 3 times in order to cancel each version of the meters that's up here. There are 2 ways I could do that. I could write it out 3 times, or I can cube my conversion factor. So now my units would be kilometers cubed divided by meters cubed, and meters cubed would cancel. Okay, so I'm going to take 10 and divide by 1,000 cubed. And I'm just going to write this out in scientific notation because I don't want to count 8 decimal places. So 10 meters cubed works out to be 10 to the minus 8 kilometers cubed. This concludes this part of Unit 1.